Hi guys, my name is Dina and today I'll be talking about mining and refining gold in the ancient world. So I wanted to make this presentation a bit more personal. When I was looking through the list of topics, gold really caught my eye and there are two major reasons. First of all, everything that relates to mining and refining metals in the ancient world, or even modern time, has something to do with chemistry. And since I'm a chemistry major, this really excites me. And secondly, I wanted to introduce you guys about gold from a chemist's point of view, which is why I decided to start my presentation this way. So I'm a chemistry major, and everything that has something to do with chemistry kind of interests me. Gold specifically has very fascinating properties. That's called its electronic configurations, which we'll go into later. It's also a transition metal, or a D block element, that is integral to something called catalysis. Catalysis is the process of increasing the rate of a chemical reaction by adding a substance known as catalyst, and it can speed up the reaction rate by lowering the transition state energy barrier. So gold catalysis and organogold chemistry is a really big developing field, hot topic right now, and some examples include these papers that were published. So after talking about why do I care about gold, let's talk about why did the ancients care about gold. Gold in Latin is called aurum, and it means shining dawn or golden luster. This aurum word is also where the chemical, elemental short form for gold, Au, came from. So some really cool things about gold include it doesn't corrode, which symbolizes immortality and power in the ancient times. So corrosion is something also called oxidation. So metals like iron, copper, and silver can be oxidized easily when react with oxygen and or water. This is known as corrosion. So for example, iron oxide is known as rust. But gold doesn't do this. It's also, so why does it not do this? That's due to its inert reactivity as a result of its unique electronic configuration, which makes it to resist oxidation unlike other metals. And this has to do with the way that electrons lay in their atomic orbitals in gold, and since this is not a chemistry presentation, I won't go too much into details about atomic orbitals and stuff. It's also a rare metal, so usually the rarer something is, the more valuable it is. It's also very malleable and ductile, meaning it can withstand tensile stress and also compressive stress. It can also make good alloys with pretty much every other metal. Gold is the first metal that's widely known to humans because it exists in this elemental form instead of a mineral ore most times. So traces of gold were found in ancient caves dating back to 40,000 BCE. And ancients cared so much about gold that they invented a field called alchemy, which aims to transform base metals to gold. Now, it's proven to be pseudoscience because you really can do transformations like that. However, alchemy built the foundations for modern-day chemistry, which means I can do what I love, owe to the ancients, because they cared so much about gold. If it weren't for them, I wouldn't have chemistry now, so I gotta say thanks to them. And another fun fact is something called aqua regia, which is 1 part nitric acid to 3 parts hydrochloric acid. Aqua regia literally means royal water, since it can dissolve gold. And it can be displaced by the same amount of, if it dissolves the same amount of silver, that can displace the gold. So you can make this if you want to hide some gold in the future. Just FYI. And that picture on the left is an aqua regia solution that we made in my research lab sometime last fall. Just thought it was cool to show you guys what it looks like. So gold had many uses in the ancient world. For example, it was used as a jewelry. This is a picture of a Mycenaean octopus brooch. It was also used as currency, so this is something called the Chinese yin yuan, and it's perhaps one of the oldest Chinese gold coins, but they stopped doing that for currency after this. It's also used for religious artifacts, for example, the sun disk from the Inca civilization, and it's also used to make death masks, so you put on people after they die, usually powerful, important people, such as King Agamemnon, and also the death mask of King Tutankhamun. It's also used as ancient dental material, but I didn't include a picture because it kind of looks gross. Also, something else that I observed, which is really interesting, gold is related to the sun god across many civilizations. This is very common, apparently. So, for example, gold was thought as the sweat of Inti, which is the sun god in Inca civilization. It's also believed to be the body of Amon or Ra in ancient Egypt. And according to Greek mythology, when Apollo was born, everything on the island of Delos turned into gold. So first, let's talk about Egyptians. Egyptians were the first that is known to smelt, craft, and make alloys with gold, and archaeological evidence of this activity dates back to 3000 BCE. They were also the first to formulate the value of gold, and they said that one piece of gold equals 2.5 pieces of silver. However, in ancient Egypt, gold was not used for bartering. It's more of a religious material than currency. And Nubia, which is in modern-day Sudan, was the first main gold mine of Egypt. So there were two main ways that ancient Egyptians mined gold. First one was from a river, something called auriferous sand, which literally means sand that contains gold. So auriferous sand containing gold would be put into a sack made from animal fleece. Water would then be poured onto the sack, and then the sack would be shaken around vigorously by two men. Since gold is heavy, it would stick to the fleece, and sand would be taken out by the water. This is from the riverbeds, and it can also be mined using something called fire setting in underground mining, and this is described by the Greek historian Diodorus Siculus around 60 BC. So fire setting says, you start a fire against the rock face and then you pour liquid over to crack the rock using thermal shock. However, this is very dangerous underground because they didn't have proper ventilation back then. So gold refining is also known as gold parting, and in ancient Egypt, it's mainly done through this way depicted by this diagram on my slide. So first there's grinding, which is using hand-operated mills made from granite to grind the ores or rocks. This is for non-elemental gold, obviously. This is when you have an ore. And it's washing. Washing is you start by smashing the gold-containing rock into powder and then put them on a table, wash them with water a few rounds to flush out the dirt and soil. And then there's gravity concentration, which mentioned as last slide is spinning the sack made of fleece and concentrate the gold while taking out the remaining sand. And then they melt gold using charcoal and blowpipe, depicted from diagram C between 3 and 4 on that picture. And then people also skimmed off impurities from the surface of molten gold. So this is very common in the process of smelting gold. And then sometimes they would pour it into molds to make statues and stuff, or it can be hammered into gold leaves, very, very thin, 5 micrometer thick gold leaves. And this is incredible. Apparently gold is the most malleable material, meaning it's the best at enduring compressive stress, so it's really, really flexible when you hit it with pressure. Sometimes slaves also rubbed gold particles between their hands to get out any remaining dirt before the final molding process. Also by Diodorus on cupellation. So cupellation is a way to refine gold furthermore by putting them into a small vessel called cupel, and he described it as you use fixed proportions of lead salt, a little tin, and barley bran. This mixture was poured into sealed earthen crucibles and roasted in a furnace for 5 successive days and nights. The crucibles are then opened and nothing is found in them but the pure gold, a little diminished in quantity. So this is apparently how good they were at cupellation for increasing the gold purity in ores. Lydia isn't my main focus, but I still would like to mention a little bit about the Lydians because this is something really cool and interesting in terms of the history of gold. So Lydia is modern-day Turkey, or mostly modern-day Turkey, as depicted by the graph, the map on the bottom right corner. It had a river. So this river in Asia Minor called Pactolus, which is in modern-day Western Turkey, apparently carried gold in sand, and there were so much gold that it's literally shining under the sunlight, which is probably a beautiful sight, but I googled it and the gold are gone by now. Probably long gone. So Kingdom of Lydia is the first nation to use golden coin as a currency, and this, from the historical writings, happened at 564 BC, However, it's not really widespread because it's a small nation. They weren't able to make it like a big common currency. But another important thing is the first pure gold coin was image stamped on them. On the coin was made from when the king Croesus was governing Lydia. And Lydians also refined their gold to further improve the purity of gold by using a method called salt cementation. Basically, you add the main component is salt. This method adds salt and then to the gold alloy in a furnace for temperatures 600 to 800 degrees Celsius, and then that apparently takes out the silver impurity in the form of silver chloride. And the chloride comes from salt, which is sodium chloride. Salt cementation weren't invented by Lydians, although were widely used by them. It's actually first recorded from 4th century BC India. In ancient Greece, gold was associated with gods and goddesses. Most coins were made of silver, only occasionally gold. However, there is something else called electrum that is used to make coin. It's a naturally occurring gold and silver alloy, and ancient Greeks called it white gold. So electrum is a harder material, which is why it's better at making coins, because usually pure gold is actually really soft. The picture above is a gold stater, or called the Macedonian gold stater from the reign of King Philip II. Gold stater is a premium coin type, and this coin has the head of Apollo on the front and the chariot at the back. Also, King Philip II was the father of Alexander the Great. Let's talk a bit about Greek gold mining and refining. So gold mines mainly existed in northern Greece, namely Macedonia, Thrace, and island of Thasos, and Lavrion is the main gold mine from ancient Greece. It's established around Mycenaean times, which is 2000 to 1200 BC. It didn't have much gold, it's mostly silver, but there was some gold that was produced. And it's also interesting because in nature, gold and silver usually occur together. So they did mostly underground mining, by first cutting horizontally through a surface, then penetrating deeper to have galleries with small cross-sections, and these cross-sections were so small that only young boys could walk along these gallery openings. And when ore is detected, they would enlarge the openings into chambers. They used tools such as hammers, ladders, wooden shovels, and baskets. The baskets is to take out the debris that was produced during the mining process, and obviously mining was very slow because they didn't really have some other cool techniques that Romans used later on. They used fire setting later, as the Egyptians have done, and their refining process consists of mostly smelting and cupellation. So smelting is applying heat to the ore in order to extract out base metals, and cupellation, we'll talk more about it later. And here are just this is an image of the Lavrion mine, and then this is an image of what a mine looks like after fire setting. So you can see the smoke and like the burnt on the rock surface in that picture. The Romans are kind of my main focus for my talk today. They are the first nation that attempts to make gold a widespread currency, and their major gold mine is called Las Medulas, and it's in modern-day Spain. So this happened after Spain was conquered by Roman Emperor Augustus, and Las Medulas was abandoned in the 3rd century after producing 800,000 kilograms of gold. So this was all made possible due to the genius of Roman engineering. They used aqueducts for interbasin transfer of water, and then the water contributed to all three of them pretty much mining techniques or mining methods that they had back then, which is surface mining, strip mining, and underground mining. So for surface mining, they were able to do something called hushing that reveals the mineral veins by flooding the ground with water. This is the easiest way of mining, the least riskful. And then the next thing they have is called strip mining or open cast. This basically says whenever you find like a mineral vein with ores, you just dig short tunnels through that direction, then you will find more ores. The hardest and the most risky one is called underground mining or deep vein mining. In Latin or Greek, is called rena montium. Literally means racking of the mountains. So for this one, miners would dig narrow cavities in a mountain and filling the cavity with water, which would cause a pressure that is large enough to break the thick rock walls. This is less commonly used, so it's only used for gold and silver. Nothing else is worth doing this, basically. Whereas for surface mining and open cast, they use a combination of hushing and fire setting commonly because the smoke and fumes can dissipate relatively safely. The gold production definitely contributed to Roman Empire's power and wealth. However, there were environmental impacts that was left on landscape and air pollution from their excessive mining that they've had done. For example, the natural landscape of Las Medulas was destroyed by the use of high pressure water, and mineral air pollution peaked during Roman periods in Spain. For example, the atmospheric lead level was not reached until Industrial Revolution 1,700 years later. And here's a little bit of background for the people who mined those golds for the Roman Empire. These are Roman slaves that worked really hard, and they had the most brutal lives of all slaves. They were expected to live and die in the mines. They cannot buy their freedom to be sold or to be set free. There were issues associated with underground mining, including lighting, ventilation, and drainage. But these issues were also solved somehow. So the lighting can be solved by using oil lamps. However, the temperature underground is really hot that the workers usually work naked. Otherwise, they would be sweating really hard. The ventilation problem, the first method is they had digged ventilation shafts that utilize the concept of convection, which means warm air moves up and cool air moves down. It's a heat exchange mechanism in fluids. Or they also sometimes lower a lamp into a shaft to see if there's toxic gas fumes. If there is, then the lamp will go out, basically, if there's carbon monoxide or some sulfur-containing gas. The drainage issue was solved by artificial channels, digging artificial channels for draining, or using waterproof baskets made with esparto grass to take water out, 150 liter per basket apparently. There were also mechanical devices commonly used for draining the underground mines. First one being Archimedes' screw, and second one is water wheel. So Pliny the Elder was a procurator in the Las Medulas region in 74 AD. He wrote in his book Naturalis Historia, "What happened is far beyond the work of giants. The mountains are bored with corridors and galleries made by lamplight with a duration that is used to measure the shifts. For months, the miners cannot see the sunlight, and many of them die inside the tunnels. This type of mine has been given the name of runa montium. The cracks made in the entrails of the stone are so dangerous that it would be easier to find purpurine, which is a type of dye apparently, or pearls at the bottom of the sea than make scars in the rock. How dangerous we have made the earth." Since some gold ores contained copper and silver, the Romans had to refine them, and the most common way to remove copper is called cupellation. This was developed before the rise of Roman. It basically heats the ore or alloy in a cupel under controlled temperature, and the precious metals such as gold or silver does not react, meaning oxidize, but the base metals does react. So they form slag that is separable. And then by separating gold and silver, after taking out the rest, is granulation, then salt cementation. Granulation is just pouring the hot molten alloy into cold water to granulate, and then salt cementation, as I've explained in the Lydian slide. So Pliny the Elder also wrote that roasted with a double weight of salt and 3 times the weight of missy, which is ferric sulfate, and then again with 2 portions of salt and one of the stones, which is called schiston. So this, if you don't do cupellation, basically you can use iron sulfate to take out the copper and then salt for taking out the silver. So this is like the 2 processed, joined, and made in one step, basically. Before I conclude my talk, I just want to talk a little bit about the grading of gold in ancient times. So Egyptians use a really cool method called fire assaying. Basically, they fire the metal in a small crucible that is made of bone ash with some lead. And lead and the base metals will be absorbed by the crucible, whereas gold and silver will remain. And then silver can be removed by nitric acid. Then they can know the purity of gold by comparing the weight of the stuff that's left in there before versus after. And then in Greece, I'm pretty sure we all know that Archimedes had used his specific gravity or density of metals to find the purity of the king's crown. These are the references that I had, and that's the end of my talk. Thank you so much for listening, and I'll be glad to take up any questions that you have in the virtual classroom.